Hey everyone, today we are going to implement k-fold cross-validation. In this problem, we are given a function with parameters x, which is a 1D array, and the number of folds, which is k equal defaulting to 5, and the option to shuffle the folds. And we need to give the k-fold indices the result. Let's first try to understand this with an example. We have x, which is the input ND array. Let us initialize it, and 10, 12, 13. So these are 10 samples, and let's take k as 5. That is, we want 5 folds for testing. So considering 5 folds, that means there will be 2 samples within each fold. Now let's draw the test and train folds. So we need to return the indices. So for test, with 2 samples it will be 0, 1. Then corresponding train samples will be indices of 2, 3, 4 up until the index 9, since we have 10 samples. The next fold will have 2 and 3 in the test, and the train will correspondingly have 0, 1, skipping the 2 and 3, 4, 5 until 9. Similarly, we can draw the test and train folds for the rest of the cases. So this implies that within each row there are 5 folds each, and the first fold is in test and the other folds are in train. Similarly with the other rows. So in essence we will have 5 rows because of 5 folds. Now this was the easier example wherein each fold had equal number of samples. Now let's go through the other case wherein the number of samples don't cleanly get divided into the folds. So let's take the x again as input, which has numbers ranging from 10 till 21. So now in this case there will be 12 samples. Again we will have k equal to 5. Now when we divide with the number of folds for the samples, 12 divided by 5, we will have 2 samples each in each fold, and there are still 2 samples remaining. So what happens in this case is that the 2 remaining samples get divided into the folds one by one from the starting. So let's walk through an example for this. So first fold will have test as 0, 1, 2, and corresponding train samples will have 3, 4, 5 until the index 11 because we have 12 samples. The next one will have 3, 4, 5 as test, and 0 till 2 will be the train, and next from 6 to 11 will also be in the train samples. So first 6 indices actually get covered in 2 folds. Now let's go with the third example wherein the test will be the indices 6 and 7, and the remaining will go into the train. So they will be 0 up until 5, then from 8 till the index 11. Similarly, let's go fast with the remaining examples. Test will be 8, 9, then it will be 10, 11, and we will have corresponding train examples, which will be from 0 to 7, then 10, 11, then the last one will be from 0 until the index 9. So again we have 5 folds but with varying number of samples in each fold. So as you can see, now the samples will be divided in 3, 9 and 3, 9. Then the test will have 2 samples and train will have 10. So this is how k-fold works, wherein the proportion is maintained by switching the number of indices within each set. Now you can pause the video here and try to figure out the code solution on your own and then return back to the video. Alright, now we can jump into the code. Let's initialize number of samples first, which will be equal to the range of numbers in x, so it will be the length of x. Next, let's initialize the indices array, which will be the range of numbers for x. So for 10 length array, it will be 0 to 9. If we take in the shuffle, then we should randomize the indices. Now let's create the fold sizes. Fold sizes can be created by using np full. We take in the number of folds and the number of samples within each fold. Let's put the type of this to int. So let's understand this once again. Fold sizes implies the number of samples within each fold. So we had the separation of 2 and 8 for 10 samples, but that isn't the fold sizes. The fold sizes will be 2 each. Within each fold, we will have 2 number of samples. Now let's do it for the second example which we had, wherein we have 12 samples. So the folds will be of 3, 3, and the remaining ones will be 2 each. So it will become 3, 6, 8, 10 and 12. That is how the folds of the samples will be divided. Alright, now let's jump back into the code. Alright, now to handle the second case, we will take the remainder of samples, and up until that index we will increment each fold size by 1 so that we take in all the samples. Now let's initialize folds as an empty array. This will contain the indices for each fold, and now we should do current equal to 0 so that we can capture the fold sizes. We iterate from each fold size, and the start will be the current and stop will be the current plus fold size. And we should set current to stop so that for the next iteration it can start from the last index. Alright, now let's initialize the result. We already have the fold indices and we need to enumerate for this fold sizes because we need the index. So the current fold can be the test fold, and the remaining ones which will be the train indices. So we need to concatenate the train indices for folds up until I and from folds I plus 1. Let's put the tuple of train and test in the result, and that's it. The whole code is implemented. Okay, now let's try to run the code to see if it is working. We have an error. NumPy is not defined. Let's run that again. Alright, so this works. Now let's try to run it. Let's initialize the input array from 10 to 21. Let's take the 12 sample case. So printing the total number of samples. Right, we have 12 samples. Let's initialize k folds. Use the function which we just implemented. Use x and set k equal to 5. For now, let's just do shuffle as false. And let's print the train and test indices. Let's add a line separation between each sample so that it becomes cleaner. Printing, we have the train and test samples like we discussed in the examples. We have 0, 1, 2 and corresponding train samples, and similarly we have the remaining folds. Now let's try to validate that the implementation which we have done is absolutely correct. Let's jump into the section for verification. We import sklearn model selection k fold, and let's initialize k fold with number of splits equal to 5, and again let's just do shuffle as false. For making it faster, let's copy the code from above, and since we need to change k folds, this will become k fold dot split, and let's put in the x parameter. Running it, we get the same result. You can check the first test and train are similar. Similarly, the other results are also same. And that is how we implement k-fold cross validation. Thank you for watching.